Hello, this is Min Treatment, and this is my presentation for Human-in-the-Loop Robotic. So, what is Human-in-the-Loop? Human-in-the-Loop, or HITL for short, is a model that humans remain an active part of the decision-making process. Instead of the robot operating entirely on their own, humans provide command, feedback, and supervision. It's a collaboration between human and machine. This approach is essential when full automation isn't possible, like space exploration or delicate surgery. In typical human-in-the-loop setup in robotic, there's a continuous cycle. The human send instruction to the robot, and the robot act in the environment, and sensor data is sent back to the human, so they can adjust their command. This loop allow us to combine the human strength, which is judgment, adaptability, and creativity, with robotic strength like precision, endurance, and the ability to operate in dangerous places. Teleoperation. Now that we understand the concept of human in the loop, let's look at one of the most direct applications in robotics: teleoperation. Teleoperation means operating a robot at a distance. The human send command and the robot execute them in real time or near real time. This approach is useful in environments that are dangerous, inaccessible, or too delicate for a human to be physically present. Think about nuclear plants, underwater exploration, or even space mission. In teleoperation, the human is continuously in the control loop. The operator provides main intelligence, while the robot acts as an extension of their hand, eyes, or tool. So, so there's one big issue that teleoperation have, which is latency issue, because the operator depend heavily on the feedback from the robot. This can be video, sensor data, or haptic feedback, and any delay like network latency can make precise control harder. Later, we will see how technology like VR, AR, and haptic feedback make teleoperation more immersive and effective. So, as we can see here is two examples of teleoperation. The first one is Valkyrie robot teleop in simulation. So Valkyrie is an advanced robot designed to operate in degrade or damaged human engineered environment. NASA hopes to eventually send Valkyrie into space, to the moon, and even Mars. And this machine is Da Vinci surgical robot. It's a robot that allows surgeons to perform complex procedures with high precision. It supports smaller incisions, typically 1 to 2 centimeters, which help reduce trauma and improve recovery. Moving on to mixed autonomy. With teleoperation, humans fully control the robot remotely, which work well for high-risk or precision tasks, but it also demands constant attention. Mixed autonomy, on the other hand, where both human and robot share the control, and the level of autonomy can shift dynamically depending on the task and environment. In short, mixed autonomy builds on the human-in-the-loop concept by enabling smarter, flexible teamwork between human and robot, paving the way for more robust and intuitive human-robot system. So there's two examples of that, which is lane centering assistant, where the car are automatically adjust your steering to keep you centered in the lane, but a human remain responsible for other driving tasks and intervene when need, like braking, accelerating, and change lane. The second one is commercial plan autopilot, where the system will handle cruising and navigation while the pilots will take over during takeoff or landing. VR in robotics. VR or virtual reality is a technology that create a fully immersive digital environment, allowing users to feel present inside a computer-generated world. In robotics, VR used to enhance teleoperation by providing operator with a first-person 3D view of the robot's surrounding and its perspective. This immersive experience improves situational awareness and precision control. Instead of just watching a 2D video feed, operator can now look naturally, judge distance better, and control robot more intuitively. VR also enable training and simulation, which can help the operator practice complex tasks in a safer virtual environment before controlling the real robot. When combined with haptic feedback that we will discuss later on, VR can make remote robot control almost like physical being there. On to AR in robotics. So AR or augmented reality, unlike VR, which replaces your view entirely, AR overlay digital information onto the real world, as you can see here, enhancing what you see without fully replacing it. In robotics, AR help operator by displaying critical data like sensor reading, robot status, or navigation cue directly in their field of view, usually through smart glasses or tablet screen or even a VR. This real-time overlay improves situational awareness and decision making, allow operator to interact more naturally and effectively with robot. The image here is in AR that shows the safety zone, which is the green area, and the robot working area, which is the red one. Haptic feedback. So haptic feedback is the technology that allows user to feel what a robot is touching or doing remotely through tactile sensation like vibration or force. In robotic teleoperation, haptic let operator send texture, resistance, or weight as if they were physically manipulate object, greatly improving precision and control. For example, a surgeon using a robotic system can feel the tissue stiffness during a procedure, uh, helping avoid excessive force on tissue. The picture is the Da Vinci 5, which introduced force feedback technology, a haptic feedback system that allows surgeons to feel the force exert on the surgical instrument, providing a more intuitive and controlled surgical experience. Combining haptic with VR or AR create a more immersive and intuitive control experience, enabling operators to interact with robots more naturally and safely. So integrating VR, AR, and haptic in in the loop. So VR immerse the operator in the robot environment, giving a first-person view for precise control, while AR add real-time digital information over the real world, helping operator understand the robot status, surrounding, and alert without losing awareness of their physical space. And then we have haptic feedback. Let operator feel what the robot is touching and manipulating, bringing a sense of touch and remote control. And also we have the benefit, which is when these three technology can work together, they enable more intuitive, accurate, and safer human-robot collaboration. Operator can see, feel, and react like they are physically present with the robot. This integration is especially valuable in delicate tasks like surgery, hazardous environment exploration, and complex industrial automation. So the challenge that human in the loop face is that while integrating human into robot tech control through VR and haptic VR, AR, and haptic feedback bring many benefits, there are also significant challenges to overcome. First is the technical challenge, include latency and communication delay, which can disrupt the operator's sense of presence and control, especially over long distance. Second is the system complexity is a big trouble. Uh, VR, AR, and haptic requires sophisticated hardware and software integration to perform consistently, which can be costly and difficult to maintain. Third is we have user factors such as operator fatigue, cognitive overload, and learning curve must be addressed to ensure effective and safe use. If the interface is too complicated or overwhelming, operator might make mistakes. Finally, safety and reliability are critical. System must be fail-safe because error in control can lead to serious accident, especially in application like surgery or hazardous environment. Future trend. Although there's many challenges looking ahead, there's several exciting trends are shaping the future of human-robot collaboration in human-in-the-loop, teleoperation, and mixed autonomy system. First, we have the AI and machine learning. We make robots smarter and understand human intents, adapting autonomously and predicting operator need, making control smoother and safer. Second, we have 5G and beyond communication network will drastically reduce latency, enabling near real-time remote control over much greater distance. Third is we have advanced sensing and perception like improved 3D vision, tactile sensor, and biofeedback will provide richer data for human and machine to work together. Finally, as trust grows, we expect more collaborative robot working side by side with human in factory, home, public space, seamlessly shifting control and autonomy when needed. That's all. Thank you for watching.